Good day, class. In this class, we are going to prove that the coefficient of friction on an inclined plane is given by tan theta. Let the coefficient of friction be mu, that is mu is equal to tan theta. That's what we are going to prove in this lesson. As you can see, this is the body of mass m on this inclined plane that is inclined at an angle theta to the horizontal. Now, let us first of all analyze the forces that is acting on this body. The first force we are going to consider here is the weight of this body, which is acting perpendicularly downward. And we all know that the weight of a body is equal to mass times acceleration due to gravity. Now, the next thing here is what? The normal reaction of this mass on the plane. The normal reaction will be acting perpendicular to this plane. That is, the normal reaction will be like this. It will be perpendicular to the plane. So this is the normal reaction. Now, the next thing we need to take a look at now is that let us extend the line of action of this normal reaction backward like this. Then we draw a line from this point that is parallel to this plane so that it will meet this line of normal reaction at right angle, that is at 90 degrees. By geometry, this angle theta is also equal to this angle theta. Now, this part is the component of this weight that is perpendicular to the plane. Let us call it W subscript Y. And the component of this weight that is parallel to this plane is this one. Let's call it W subscript X. Now let us remove this right angle triangle and work with it. We have something like this. This is the weight. This is the angle theta. Now this is the component of the weight perpendicular to the plane, and this is the component of the weight that is parallel to the plane. Of course, since this is a right angle triangle, you can apply SOHCAHTOA here. Now, we know that sine theta is equal to opposite over hypotenuse, which is W subscript X over W. Then when we cross multiply here, we have W subscript X is equal to W sine theta, and W is mg. From here, this will be mg sine theta. What it means is the component of this weight that is parallel to the plane is mg sine theta. Now, which is this one? Let us transfer it to this place. Here we have mg sine theta. Now, what next? Let us find the component of this weight that is perpendicular to the plane. From here, we know that cos theta, which is equal to adjacent over hypotenuse, it will be W subscript Y over W. When we cross multiply here, we have W subscript Y is equal to W cos theta. As we all know that W is mg, then which is known as mg cos theta, which is this one. Here is mg cos theta. It does not stop there, because mg sin theta would like to drag this body to come and rest here, but frictional force will go against the motion. For that reason, frictional force will act in upward direction, which is F. Now at equilibrium, what happens here is that at equilibrium, this force, frictional force here, must be equal to mg sin theta. This implies that F is equal to mg sin theta. Let's call this one equation 1. And at equilibrium again, this normal reaction R is equal to mg cos theta. Then we have R is equal to mg cos theta. Now let's call this one equation 2. Now, when we divide equation 1 by 2, we say equation 1 divide by equation 2. This implies that F over R is equal to mg sine theta over mg cos theta. Here, mg sin theta will cancel this mg sin theta. We have f over r is equal to sine theta over cos theta. Now, we need to note something here. From the general law that governs friction, we say frictional force is proportional to the normal reaction. When we remove this sign of proportionality, we introduce our constant, which is the coefficient of friction. F is equal to mu r. Then from here, F divided by r is equal to mu. For that reason, this ratio F ratio r is equal to mu, which is equal to sine theta over cos theta. And by geometry or by identity, sine theta over cos theta is equal to tan theta. Therefore, mu, which is the coefficient of friction, is equal to tan theta. Thank you very much.